In this video, we're going to talk about lesson 4.3, problem 6. So let's read the problem. So we have populations, and the population in 1,052 cities are collected in the graph, and the summary statistics of this data are given in the JMP applet. Now, all of the statistics that we need are in this applet. And so when we click on it, we're going to get what we need, okay? But the first thing we need to realize is, here's the applet, so we'll click on the applet. And I want you to notice in the applet, we have all the information that's needed. We got a box plot. You can see all the outliers in red here. And then we have a bar graph that's associated with it. And then underneath that, we have all the necessary information that we're going to need in order for the calculations that this problem asks for, okay? So anyway, let's get down to the questions and then we will work the problem. Let's say, they ask us to determine the interquartile range. Well, what do we remember what we need for quartile range? We need Q sub 3 minus Q sub 1. And Q sub 3 is here. It's the 75th quartile, and it is 193,275. Now I'm going to copy that down, and then we'll go to the document cameo and I'll work the problem for you. Q3 is given to be 1932.75. Okay, and we need also Q1, which is the 25th. Q1 is equal to 447.25. Okay, and we're asked to find the interquartile range, okay? So I'm going to go there and we'll work the problem. Fair enough? Sorry about that. So I'll stop my share and go to the, well, we're already there. Sorry, I didn't need to. And you'll see the two values that I have here. See if I can get this thing to focus here. Sometimes if you just lay your pencil in there, it'll focus better. Well, Q3 was 1932.75, and Q1, there it is, 447.25. So the IQR, which is the interquartile range, is equal to Q sub 3 minus Q sub 1, which in this particular problem is 1932 0.75 minus 447.25. Okay. So if we get our trusty calculator out here, and we put down 1932.75 minus 447.25. We have that the intercontinental range, the quartile range, excuse me, is 1,485.5. Okay. We've done this before, so let's go back to the problem. Okay. We share that. We determined it was 1,485.5. So that's what we have there. Okay. Now let's go to the next question. What percent of the data is represented by this range? Well, the upper quartile is 75%. That means there's 75% of the raw data items below the quartile and 25% above. And the lower quartile, there's 25% below and 75% above. So if we take the 75% minus the 25%, we get 50%. So the answer to that is 50%. Okay. That wasn't difficult. Now let's go to B. What value separates the upper 10% of the data from the lower 90% of the data? Okay, let's see if we can find that. I think it's given right here. This is the 90 percentile, we call it. Okay. And it's 4,147.2. 4,147.2. It separates the top 10%, that's here, and the lower 90%, which is here. Okay, so I'll write that down. Four, 1,447.2. Okay. Now see, which cities are considered upper outliers according to the IQR method? Now, if you remember, we'll go to the document camera and I'll work it out for you, but if you take the upper quartile, which is Q3, and you add to that 1.5 times the IQR, okay, you'll get a number. And any data item that is greater than that number is an outlier. So let's do it, and we'll go to the back of the camera and we'll work it out, okay? And we'll find what it is, and then we'll look at each one of these values that are given and see if they are an outlier, okay? So I'll stop the share, and I'll go here. Okay, now we've got everything that's needed right here on this sheet. To find that mark in which we want anything above that mark is an outlier, we take Q3 and we add to that 1.5 times IQR. That's the IQR method, okay? And that is equal to 1932.75. That's what Q sub 3 is, right? And then we're going to now add to that 1.5 times IQR, and IQR is 1485.5. Okay. So that's the formula. Anything that's above this number will be an outlier. Okay. So if we take our trusty little calculator and we'll do 1.5 times 1485.5, that'll give us, it's equal to 1932.75 plus 2228.25. Okay. So if we add now 1932.75, we have, this comes out to be 4160. So any population that's larger than 4160 is an outlier. Okay. So now we have to go and check. Okay. So we, with our screen, check the problem. What about Los Angeles? Well, if we check Los Angeles, what's the population in thousands of Los Angeles? It's 8505. Well, 8505 is larger than 4161. That was our mark. Anything larger than 4161 is an outlier. So Los Angeles is an outlier. So we'll go down and check Philadelphia. Let's see, what about Philadelphia? I can find it. Philadelphia, 4,866, which is greater than 4160. So that's an outlier. So check that one. Well, you see how it's done, and you can see that Chicago, Detroit, and New York are all outliers. Houston is not, and Washington is not. So that's, and you see how I did that. I just checked each one against the 4160. Okay, now about D. Now we want to find out which one are the lower outliers. Well, I'm going to go now. The lower outlier is on the other end of the box plot, which is Q1 minus 1.5 times IQR. Well, we've got that multiplied. That's when I multiplied that times that. So I'm taking Q1 and I'm subtracting, and when I multiply this times this, I get 228.27. And Q1 is 44725. So this is 44725 minus 2228.25. Well, now look, since this the magnitude of this number is greater than the magnitude of this number, when I subtract, I'm going to get a negative, right? It's going to be a negative value. And if I do that, what do I get? 228.75. I get a negative 1781.5. Now, none of the population is negative. So there's not going to be any number of the population that's going to be smaller than 1,000, negative 1,081.5. So because that's the situation, we can go back and share, and none of these, because they're all positive, is going to be less than a negative number. So that's the problem.